So we're going back to section 9.2. See, we've already done section 9.3 and 9.4. That was graphing parabolas, and that was both in vertex form and standard form. So we've been graphing. We've been able to find the vertex. In standard form, we would find the vertex with x equals negative b over 2a. In vertex form, you could just see that the vertex is hk. We also know how to graph with the a value pattern. If the a value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. If it's other than 1, you could modify it. We've even talked about transformations of parabolas and stuff. But today, we're going to go back to section 9.2 and show you how to solve quadratic equations by graphing. So the main concept for this lesson that we're recording is to understand that all these words mean the same thing. Answers, solutions, x-intercepts, roots, zeros, all those words mean the same thing, okay? So in your notebooks, I would write down that list of words and just write down, they all mean the same thing. So again, I repeat, all these words mean the same thing. On the final exam, you're probably going to see a quadratic equation. They're going to say solve it, right? Find the solutions or find the answers. But they may also say just find the roots. And if you don't know this list right here, you're not going to know what the heck they're talking about. Find the roots just means solve it. Or find the zeros. What the heck does that mean? That just means solve it, right? Find the answers. Find the x-intercepts. What does that mean? Solve it, right? So I hope we remember from before that if they ask you to find the x-intercept of any equation, how do you do that? How do you find the x-intercept? Set y equal to 0 and solve, right? So if they tell you find the x-intercepts of this guy, you set y equal to 0 and solve. And it's pretty much the same thing as asking you to solve this guy with equal to 0. The only difference is that over here you have the equal 0, and over here I have the equal 0 on the right side. But it's really the same thing. So that's an example right there of the words find the x-intercept meaning the same thing as solve or find the answers. It's the same exact thing, okay? Which also means that you could solve it using the old method from a previous chapter, which was factoring, right? Do you guys remember how to factor? Quadratic trinomials that have an a value of 1, they're really easy to factor. You could automatically start up your factored form format and put an x and an x right there because x times x is x squared. And then we simply think what times what is our c value that if we combine together is our b value, right? And you could make a list. This is the shortest list ever though. What times what is 3? It's either 1 times 3 or change both signs to a negative 1 times a negative 3. Anyways, does that pair of numbers add together to give you the middle value 4? Yes, it does. So you would put a plus 1 right there and a plus 3 right there, and they're still an equal to 0. And why would I want to factor a quadratic trinomial to become a binomial times a binomial? Because now I could split it and solve it with zero product property. Does this ring any bells? You guys don't remember this from the factoring chapter where we factored and split and solved? So again, you factored it. You see, this right here is the same exact thing as these two together. If I were to multiply, and then combine like terms, I'm going to get back to where I started from. So I didn't have multiplication here. Now I do have a binomial times a binomial. And the reason why we did that back in the factoring chapter was to split it and say that first x plus 1 could be equal to 0, and that second x plus 3 could also be equal to 0. That means that we're going to get two answers. X equals negative 1 if you solve it, right? And over here, minus 3 also if you solve it. And those are your two answers. X equals negative 1, x equals negative 3. So if somebody told me, or if the, let's say, final exam told you, solve this equation, well, you're going to factor it, split it, and solve it, right? But solving it is the same thing as finding the x-intercepts. So if you were to treat this equation as a standard form quadratic trinomial y equals x squared plus 4x plus 3, like it is up here, and you graphed it by doing the vertex form negative b over 2 times a, and then that's a vertex formula, then you could plug it back in to find the y value of the vertex, or to make it easy, graph it on Desmos, and this is what you're going to see. When you graph it on Desmos, you're going to get this parabola. And since we know that x-intercepts are the same thing as solutions, or the same thing as answers, the same thing as roots. So when I graph this, I automatically see that my answer is negative 3 and negative 1, which is the same thing as what we did down here, but we did it algebraically, negative 3 and negative 1. Make sense? So today is actually good news. It's great news. Because instead of using factoring methods and all this stuff, you could just open up your Chromebooks, get your Desmos app open, or go to Desmos.com and type in your standard form quadratic trinomial function and then identify your x-intercepts, and those are your answers to the equation. You don't have to solve anything. You just graph it, and wherever it crosses the x-axis, that'll be your answer to the equation. So we have a worksheet right here. So on this worksheet, it says solve each equation by graphing. Now I would definitely, well, because they say solve by graphing, I would at least attempt to solve it by graphing. Now, what does that mean? Graph it, and the x-intercepts will be your solutions, right? But if you actually tried to graph it the old way that we used to graph it, you would start by finding the vertex, which is x equals negative b over 2 times a. And when you use that formula and you plug in the b value of negative 5 and the a value of positive 1, you're going to get positive 5 over 2, which is a decimal 2.5. Now, at that point, I would I wouldn't want to do it. We could continue graphing by hand, but at this point, I'd be like, man, this is not a good method. I would jump straight to Desmos, right? And if you did graph it on Desmos, you'll instantly be able to see, look, I graphed it right here, but how are you going to graph it on Desmos? First of all, there's an equation that only has x's and it's set equal to 0. If you want to graph it on Desmos, what you have to do is first make sure that it's equal to 0 and then get rid of this and replace it with the y equals in the front. So as you can see, that's what I did right here. I put y equals and then the x squared minus 5x plus 6. I put that right there. And when you type it in, you're going to be able to instantly see where it crosses the x-axis. And these guys will be your solutions, right? You saw how we got the x value of 2.5? That's the vertex x value. If you plugged it back in, you'd get a y value of negative 1/4. So that gets really complicated if you're trying to graph by hand, especially if you're trying to use the pattern. But anyway, if you graph it with Desmos, you'll be able to instantly see that the answers are positive 2 and positive 3, right? You guys agree with me right there? You understand what I'm saying? So the x-intercepts are positive 2 and positive 3. So that means that the vertex is right here, and it is opening up. But in reality, we want the answers, and we see that by trying to find the vertex, man, we're already getting some crazy, nasty decimals. So it's probably better to use a graphing app like Desmos. Or you could also try to do it algebraically. Back in the chapter of factoring, when we had an equation that was set equal to 0, especially if it was a quadratic trinomial that didn't have a number out here, you could easily think about factoring, putting an x and an x and thinking, what times what is my c value that if I combine together is my b value? And you might want to make a list, 1 times 6, 2 times 3. Now, which pair of numbers combines together to give us the middle value, negative 5? 2 and 3. Now, if I do add 2 plus 3, I'll get a positive 5, and we know we want a negative 5. So we have the right numbers, just the wrong signs. So change that sign, and that's the correct pair of numbers that you want. That'll be a minus 2 and a minus 3. We have factored. Why would I want to factor? Why would I want multiplication instead of what I originally had? Well, because if you have multiplication and set equal to 0, you could split them and set them each equal to 0 and solve. So if you did say, well, x minus 2 could equal 0, and also the x minus 3 could equal 0, then you could easily get your two answers, which will be what? X equals positive 2 and x equals positive 3. So we got the two answers very quickly. How? By factoring, splitting, and solving. We factored it, we split it, and we solved it. Now this worksheet, they want you to understand that graphing, and I don't know why they would give you this problem, because you get decimal values. It's pretty complicated. But if you graph it on Desmos, you'll easily see that the x-intercepts are 2 and 3. And if you know what I taught you today, that the x-intercepts are the answers, then you already have the answers. X equals 2, x equals 3. Pretty easy, pretty cool, right? So the x-intercepts are the answers. So let's go back to the words that I was talking to you guys about right now. Answers, solutions, x-intercepts, roots, zeros. And we all saw that x-intercepts are the same thing as solutions or answers, because to find the x-intercept, you got to set y equal to 0, and it becomes an equation that you solve, that you can find answers to. How about roots and zeros? So if I asked you to find the solutions to this equation, if I told you solve this equation, go ahead and write that equation down right here, x squared plus 6x minus 9. Write that down in your notebooks. I want to copy it and write it down here. And just write down solve. Solve. How are you going to solve that problem? Any ideas? Well, algebraically, like let's say you want to solve without graphing, right? Let's say you want to solve without graphing. How would you solve it? First, you got to make sure what? That everything's on the left. If you want to factor, split, and solve, you want to make sure that it's equal to 0. Plus 9, rewrite it, x squared plus 6x plus 9 equals 0. So what was step 1? To set it equal to 0, right? And that right there kind of tells us why they use the word zeros as the same as solving or finding the answers. Like if we look at our list again, if I tell you to solve it, if I say find the answers or find the solutions, that could be the same thing as finding the zeros. Why? Because in order to do that, you have to set it equal to 0. Hence, you're finding the zeros, right? Or even if you're trying to find the x-intercepts, how do you find the x-intercepts? Well, you set y equal to 0, hence finding the zeros, right? How about roots? Well, let's continue solving this guy. It's a quadratic trinomial. I could factor it, I think. X right there, x right there. What times what is 9? That if I add together is 6. 3 and 3, right? So positive 3, positive 3. Now, normally, I would just say, okay, I could use zero product property. Something times something equals 0. The first something, I could set it equal to 0. The second something, I could set it equal to 0. But just for the sake of relating all these words on our list, I'm going to rewrite this bad boy, this x plus 3. I'm going to rewrite it as a binomial times itself, x plus 3 squared, right? You got x plus 3 times x plus 3. I'm going to rewrite it as x plus 3 squared, and it's still equal to 0. Now, if I wanted to solve, what I would want to do is get rid of everything except x. How do you get rid of something? You do the opposite. What is the opposite of the power of 2? What's the opposite of square? How do I get rid of a square? With the square root. With the square root, right? So if you apply a square root there and a square root there, then you'll get rid of the square, and it'll say x plus 3 equals 0. And then you could solve it, and what do you get? X equals -3, okay? Now, the reason why I solved it this way by rewriting it as a binomial squared is so you could see that you applied a square root to be able to solve it, and that's where the word root comes from on this list of words that means the same thing. So if I told you find the answers, find the intercepts, find the roots right there because you applied the root. Why could they say find the zeros? Because you had to set it equal to 0, right? Or to find the x-intercepts, you set y equal to 0. So all these words mean the same thing. Anyway, let's think about this, guys. If we know that this quadratic trinomial, which is a parabola, right? Does a parabola open up or down? Up, right? It has a pattern 1, 1, 2, 4, 3, 9. If I wanted to, I could find the vertex by doing -6 over 2 times 1. But I'm not going to do that. What else could we say about this? We just found the answer, the solutions, the roots, which are the x-intercepts. So graphically, this parabola is going to cross the x-axis where? At -3. And that's kind of strange because normally when we think about a parabola crossing the x-axis, we think of it passing at 2 locations, right? One right there and right there, right? But in this case, it's just one answer. So what does that mean? That maybe the parabola doesn't look like the red one. Maybe the parabola just touches at -3, then comes back up, right? That's what it means. So it only has one answer. So it's possible to have one answer the way we did right here, kind of like this green parabola does, touches at the x value -3, or it might touch at two locations, maybe like -3 and -11, right? Who knows? Or maybe your parabola doesn't even touch the x-axis at all. Now, what would that mean? If I told you to solve an equation, and instead of solving it algebraically, you graphed it on Desmos and you saw that it didn't pass at all, you're looking for the x-intercepts because the x-intercepts are the answers. If it doesn't have any x-intercepts, what does that mean about answers? That it doesn't have any answers. Any real answers, that is, so you would say no solution. Is all this making sense to you guys, or is it just a bunch of mumbo jumbo that I mean, it makes sense to me, but then again, I've been teaching for 20 years, so I hope you guys are understanding what I'm saying here. Once again, a quadratic equation, this is a quadratic equation. It could have one answer, like we did right here, or it could have two answers, or it could have no answers. It doesn't cross the x-axis. It could have one x-intercept, two x-intercepts, or no x-intercepts. Okay? Anyway, so let's go back to the worksheet. Oh, on this one, I actually did all the work by hand, and you see how nasty it is. I got the 2.5 for my x value. Don't copy this down. You could just watch. I got the 2.5, and then I plugged in the 2.5 in the x locations, and I did the math, and I got 6.25, take away 12.5 plus 6. I got out negative 0.25. So 2.5, negative 0.25, we got it right there. And then I plugged in more values to get the parabola. Don't graph it, but obviously on Desmos, it's a lot easier. Let's take a look at this guy right here. So we could graph it by hand by finding the vertex, x equals negative b over 2a, but let's not do that. Let's get comfortable with Desmos. So everybody take out your Chromebooks right now, open up to desmos.com, and type this in. But if you're wondering, how do I type this in, especially if we're used to seeing y equals x squared instead of w squared, I jotted down the notes right here real quick. Okay, so you want to first set the equation equal to 0. And number 2 is already set equal to 0. Step 2, instead of w's or b's or whatever, let's rewrite it as y equals a standard form quadratic, ax squared plus bx plus c. And this is what you type in. You graph it on Desmos. That's step 3. And then after you graph it on Desmos, just look at the x-intercepts where your parabola crosses the x-axis, and those will be your answers, right? So right now, I would like everybody to go to number 2, go to Desmos, and on Desmos, what are you going to type in? You're not going to type in w squared. What are you going to type in on Desmos? Y equals, what else am I going to type in on Desmos? But instead of w, we're going to write it as x squared plus 6x plus 9. This is what I type in on Desmos. And when I graph it, I'll be able to see the x-intercepts. Now, of course, if I were to graph it by hand, I'll be able to see the x-intercepts right here, right? But it's easier to just graph on Desmos. Might as well get comfortable with that. Okay, so I just graphed it on Desmos. Here's my original, and here's what I typed in. Y equals x squared plus 6x plus 9. And as we zoom to see the parabola, you will see that the parabola doesn't cross at two locations. It only crosses at one location, which is right here. So the x-intercept is what? Where does it cross? -3. So if you know your x-intercept, you know your answers. You know your solutions. So what's the answer to the original equation? W equals what? -3. Easy, right? So today, all you're doing is first of all, you got to understand those words mean the same thing. That if I tell you to solve it, you could graph it and find the x-intercepts, and the x-intercepts are the solutions. They are the answers. They are the roots. They are the zeros, whatever you want to call them. All those words mean the same thing. So I graphed it on Desmos, didn't graph it by hand. Of course, you could have graphed it by hand, and you would see that it crosses right here. So if you were to graph it by hand, by doing the vertex formula, you would see that it crosses at -3. And from that point, you use the pattern 1, 1, 2, 4, 3, 9, 1, 1, 2, 1, 2, 3, 4, 3, 5, 6, 7, 8, 9. I'd be off the graph. You map it over to the other side of your axis of symmetry. It would be right here, right there, and off the graph. Anyways, you would see that your answer is right here x equals -3, or better said, w equals -3 because we're talking about w's. How about this next one? If you graphed it on Desmos, first of all, how would you type it into Desmos? Could somebody tell me how I would type it into Desmos? Y equals x squared minus 3x plus 4. You just replace the b's with x's. That way it works out nicely on Desmos. And then graph it, and then see where it crosses the x-axis, and those will be your answers. Okay? So go ahead and do that. No solution. Exactly right. Why is it no solution? Because it doesn't cross, right? I think I have it up here, maybe. That's not it. Yes, I do. There it is. Y equals x squared minus 3x plus 4. And if you look at the graph, it does not cross the x-axis. So if I'm trying to solve it, trying to find the answers, what I'm really trying to do is find the x-intercepts. And if it doesn't have x-intercepts, that means that it doesn't have answers, doesn't have solutions. So what do I say? I say no solution. No solution. Or there's no real solution at least. Later on, we'll learn about imaginary solutions, but not right now. Right now, we just say no solution, does not cross the x-axis. So once again, here are the steps. Step 1, set the equation equal to 0. Step 2, rewrite it as y equals ax squared plus bx plus c. Step 3, graph it on Desmos. Find the x-intercepts. Those are your answers. Now, notice right here the instructions to 4, 5, and 6. By the way, this is all we're doing today. We're getting comfortable with Desmos. And on the instructions on 4, 5, and 6, it says solve each equation by graphing. I don't even want you to do it by hand. I want you to do it on Desmos. It says if the integral roots cannot be found, if your nice answers, if your nice answers can't be found, like as in they're crazy decimals, go ahead and estimate the roots to the nearest tenth, okay? So if you go through and graph this guy, first of all, how would you type it into Desmos? Y equals x squared plus 4x minus 3. Perfect. Okay, so the key is first make sure that it's equal to 0. So subtract 3, and then you'll be able to get this quadratic trinomial that's set equal to 0, but instead of equal to 0, put y equals in front of it. And when you graph it, here it is, y equals x squared plus 4x minus 3. When I graph it, I see that my x-intercepts are here and here, but when I click on them, there are some nasty, crazy decimals, negative 4.646 and 0.646. So these are technically irrational, crazy decimals. But on the instructions, it says just round it to the nearest tenth, right? So right here, you would just write down x equals, or wait a minute, is it even x? No, they're p's. So you would say p equals, for number 4, p equals negative 4.6, because rounding to the nearest tenth, that 4 doesn't change a 6 to a 7. And also, p also equals positive 0.6, and that's it, nearest tenth. But later on, we're going to learn that these decimal values are actually crazy irrational numbers, and we're going to represent these crazy irrational numbers with square roots, right? But not today. That's for tomorrow. So there's only 2 questions left. I would like you guys to understand that all those words mean the same thing. Find the answers, the solutions, the roots, right? The zeros, the x-intercepts. I want you to understand that. I want you to be able to set your equation equal to 0. I want you to be able to rewrite it, type it in as y equals ax squared plus bx plus c, graph it on Desmos, identify your x-intercepts, which are your answers, or your roots, or your solutions, or whatever you want to call them. And the answers are on Google Classroom. Only 2 more questions to do. Stop on number 6. And for homework, maybe just rewatch this video so It'll help you understand it better. And tomorrow we're going to move on to quadratic formula, which is fun with the capital F. All right, we're done.